Hello, and welcome to today's lesson dealing with cloning. This is the last part of Unit 1, and it deals with the idea that we can actually clone different living things. And so in horticulture, in agriculture, we do this all the time with plants because we can take cuttings and do vegetative reproduction to make clones of plants, right? So if you've grown strawberries, you can produce clones of your first strawberry plant and have a whole bunch of them. They are all genetically identical, and therefore we call them clones. However, way back in 1997, in Scotland, where they know lots about sheep, they actually cloned the first mammal. They cloned the sheep named Dolly. And so we are able to clone animals as well. And so this lesson will deal with three types of cloning. One, cloning species. The second would be cloning certain types of cells, tissues. Okay, so we can do that, and that's helpful for different types of therapies if someone gets an injury. Okay, and the third type would be the idea of cloning extinct species that have been dead for some time and bringing them back to life. Okay, that's the idea. Those three types of cloning. So, here we go. Type 1, reproductive cloning. Let's clone this beautiful sheep. Look at how happy he looks. How unintimidated of his friend he appears to be. We're going to clone him. They are not mating. They are not producing offspring through sexual reproduction. We are going to make a genetic clone of this chap, that white male, right there. So what we will do is we will take a skin cell or some other cell. And if we take a look at the cell, you'll notice that it has 2 chromosomes in there. Sheep have more than 2 chromosomes, but I'm simplifying things. Why are there 2? Because sheep, like people and other living creatures, will have 2 copies of each chromosome, one from each parent. And so from his papa and from his mama, he got a copy of this chromosome. And so we took a skin cell from this chap. We'll call him Larry. There's one of his cells. We extract the nucleus, take the nucleus out. We take a really sharp, pokey little needle, and we suck out the nucleus. Then we take an egg cell from the female, right? Females produce eggs, males produce sperm. So chickens produce eggs, humans produce eggs, sheep produce eggs. And if they would have sexual reproduction, the sperm from Larry would hopefully fertilize this egg cell and make a beautiful baby lamb. Okay? Now what do you notice about the egg cell? Oh my, it has only 1 copy of that chromosome. Because egg cells, remember, are meant to be fertilized by other cells called sperm from this guy. Whoop. And if it does, that sperm cell would also have a copy of the chromosome. And boom, this egg cell would now have 2 copies of each chromosome, baby sheep. Okay? However, that's not what we're doing here. We're trying to clone Larry. Okay? And so what we've done is we've taken a cell from Larry, extracted the nucleus, and you maybe guessed what is going to happen next. We take out this nucleus. Woo! And we throw that nucleus into the egg cell. Okay? This egg cell now thinks, oh my, I've been fertilized. I didn't notice there were sperm, but bam, I now have 2 copies of each chromosome. And so the egg cell has been tricked into thinking that it has now been fertilized. It now has 2 copies of each chromosome. Okay? So now we allow the cell to begin dividing. That's what a fertilized egg cell would do. Okay? And so we have a clump of dividing cells, right? And we call that an embryo. Okay? It is the beginning stage of a sheep life. Okay? We all began as fertilized eggs as well, and that fertilized egg divides and divides and divides and forms big, beautiful you. Okay? So now we take this embryo and we're going to put it inside the female sheep, inside the womb, the uterus, and allow for normal pregnancy. Okay? What happens? Boom! Clone of the male will be born. Look at how happy they all are. What a lovely family. Okay? Remember, the cells that we put in here were all formed through cell division from that egg cell, and that egg cell had DNA in it. Did it have any of Martha's DNA? No. We took her DNA out. It only had DNA from Larry. Okay? And so it divided and divided. And so this beautiful lamb has only Larry's DNA. Okay? And yeah, just that's the process. Keep going. And then just be careful who you clone. Okay. That is reproductive cloning, the first type. Second type is therapeutic cloning. And therapeutic cloning, this is something that we can do. We are in kind of the baby stages of this. And we will see how this field progresses. There's a lot of potential with this, but there's also some real questions. We need Christians involved in these kind of discussions. So, here is a footballer, a soccer player, and he has had a spinal cord injury. Okay? When you get a cut on your arm, right, then the cells will do cell division to repair that cut. Nerve cells are tricky. They do not easily divide and divide to fix a break. Okay? And so for thousands of years, we've known of people who become paralyzed because they have a spinal cord injury. We can read stories of that in the Bible. And it's exciting to think about, well, maybe one day we can heal those kinds of injuries. So, here's the idea. Remove one of his cells. Maybe a skin cell, doesn't matter. Those would be the easiest. And notice it has 2 copies of each chromosome. Really, humans have 23 types. So you get 23 from mom, 23 from dad. So there should be 46 in there. But we're simplifying things. Okay? It has 2 copies of each chromosome. What do? Extract the nucleus. Take the nucleus out. Okay? And put it into a human egg cell. Okay? So we find some woman, extract an egg cell from the woman, remove the nucleus from that egg cell, and put his nucleus into that egg cell. Okay? So same process so far. Allow the cells to divide and form an embryo. Right? That is what's happening in regular human reproduction. Egg cells fertilized by a sperm cell from mom and dad. And once it has been fertilized and has 2 copies of each chromosome, then it begins to divide and form an embryo, a baby. Here's where things get different though. We can take certain chemicals and apply them to this embryo and turn all of those cells into nerve cells. Normally, some of them would develop into nerve cells and some would develop into skin cells or muscle cells or bone cells. But we apply certain chemicals so that they all turn into nerve cells. Okay? And their DNA all match his DNA. Okay? And that's important because what we are going to do is we would take those nerve cells and we would place them back into his spine in the break and allow them to grow. Okay? When we give someone a transplant, like a blood transfusion or a skin transplant or let's say a liver transplant or something major like that, an organ, what can easily happen is their white blood cells kind of freak out and they say, hey, this is foreign. This is something we need to fight. And so your immune system fights against that. Here, his immune system would not fight against these because they're kind of like his cells, right? It was his DNA. So these new cells join with his spine, healing the break. That's the general idea with therapeutic cloning. Can we get that to successfully work? Maybe someday. Okay, we can do a lot of this process. We aren't at the point where we are healing spinal cord injuries, but perhaps we could. However, is there a problem? Is there an ethical issue with this process? And maybe you've kind of thought that through already in your mind. What's the issue? Well, we took an egg cell, we removed the nucleus, we put a new nucleus in there that had 2 copies of each chromosome, allowed it to divide, forming an embryo, which is basically human life, right? That was a person. It didn't look like a person, it just looked like a clump of cells. But that is what all of us once were. And we continue to develop and we change through our lives, but it wasn't a non-person that developed into a person. It was a person the whole time. And we took that person, that growing embryo, applied certain chemicals to it so that it would turn into just one type of cell, okay, nerve cells. So, is that a problem? Yeah, right? In a sense, we are killing the baby in order to heal someone else. I'm glad we can heal someone else, but it came at the cost of a life. Hope that makes sense. So we need Christians, we need you perhaps to be involved in these kinds of discussions, saying just because we can do something doesn't mean that we should. Okay. So that is the idea with therapeutic cloning. Third type, cloning extinct species. Dead woolly mammoth preserved in the ice. Are there actually woolly mammoths that are preserved in the ice? Yeah, there are. Okay, they are. They're old. They've been down there for say 1,000 years, and they are preserved in the ice. Bacteria cannot make them deteriorate. Okay, let's try a similar process. Let's take one of its cells and extract the DNA. Okay, you would need to make sure that these cells have intact DNA, and that's the tricky part. Okay, finding cells where the DNA has not actually broken down over the many, many years. Okay, extract the DNA. We now have the nucleus. Take a denucleated egg cell from a similar species. Okay, there are elephants that are similar species. Take an egg cell from a female elephant, remove the nucleus. What's next? Boom. Put the mammoth nucleus into the elephant egg cell. Okay. What do we do next? We take the egg cell and allow it to divide, forming an embryo, and put it into the mother elephant. Boom. Yeah? allow normal pregnancy, and of course we'd want to find a similar species, right? We're going to use an elephant, not a squirrel, right? The squirrel, whoop, elephant would be able to handle it. Boom! Baby mammoth. What a happy family. That is the idea with cloning extinct species. Have we ever done this? Yeah, we actually have. We have cloned various species that were extinct, and we've actually brought them back to life. That's pretty cool. So we're going to watch a little video where they talk about this process and they explain some of the science behind it.
Hey, you made your way back to 20 Minutes or Less. I'm Joe Beretta.
I'm Elliot Morgan.
Open the door, get on the floor. Everybody walk that dinosaur. We're going to talk about cloning extinct species right now. And we get it. This is a very heavy subject. The discussion of cloning is a moral roller coaster with a bunch of ups and downs, a lot of screaming, and an ending full of red-faced, breathless people staggering off in different directions.
You can't do it!
Like that guy. But look, dude, we're the last dinosaurs walking the planet, and we'd like to ensure the continuation of our species. Cloning just might be the answer. And we're not the only ones that could benefit from a resurrection.
The awesome animal lovers over at the Mother Nature Network have broken down 14 different extinct species that could benefit from a little bit of cloning. You know, in like a, oh, I was dead and now I'm not dead anymore kind of benefit.
First up is the woolly mammoth, and it seems like this hairy elephant always comes up when cloning is discussed. And for good reason. First of all sorts of intact specimens have been extracted from the ice, and today's elephants are so closely related to mammoths that scientists could utilize an elephant to give birth to a mammoth, which would be so frightening for the unsuspecting elephant mother. I mean, she'd get over it and learn to love her different baby, but she would instantly become the talk of the small-knit suburban elephant community. Did you hear about Linda?
Tell me about Linda. Who's Linda?
Oh, Linda's the one down the street. She gave birth to that hairy monster. I don't know what this elephant world is coming to.
Who is that baby's daddy?
I don't know.
Anyways, mammoths could end up being a real thing sooner than you think because Japanese scientists are looking to resurrect them in the next 5 years.
The most widely known extinct animal is probably the dodo, and that's another candidate that could stage an epic comeback. Humans drove the bird to extinction just 80 years after stumbling upon him, and the bird was unfairly named the dodo because it would walk right up to club-wielding Homo sapiens.
Hey, what you got there?
Hey, what is that?
What are you doing?
What you carrying there?
Is that a snack?
Is that food?
You want me to sit on that?
Is it in your hand? Could I perch on that?
Hey, you're my dad.
You guys are big.
In fairness, the bird wasn't really stupid, it just lived in isolation, so it wasn't used to all these two-legged creatures walking around. They are a good candidate for cloning because DNA samples are currently in museums and they're closely related to the pigeon.
Let's talk about the ground sloth.
Joe, let's. Look at the size of this thing. It's like the Hummer of extinct species. These guys walked the Earth as early as 8,000 years ago, and intact hair samples offer a DNA smorgasbord. Finding a surrogate parent, though, is next to impossible because their closest relative is the three-toed sloth, and their bodies would be ripped asunder by the giant baby growing inside of them. But someday it's feasible that a giant womb could be constructed somehow in a lab, and then we'd have a bunch of celebrities running around with ground sloths, and Kristen Bell would never stop crying.
Also discussed were the Carolina parakeet, the Moa saber-toothed cats, the Pyrenean ibex, the Tasmanian tiger, also known as the Tasmanian wolf,
The Huia, the Bayou River dolphin, the Irish elk, the passenger pigeon, the woolly rhinoceros, oh, and a Neanderthal.
and we all know that cloning a Neanderthal would be a great idea because of the scientific research paper that was Encino Man. And just in case you think this cloning of extinct species thing is impossible, well, guess what? It's happened once before. Pyrenean ibex actually became the first extinct species to ever be cloned, but died 7 minutes after birth due to a lung defect.
So there's two sides of this. One side is, yes, it would be amazing to see all of these animals roaming the earth again. The other side of it is like, hey, aren't we kind of playing God?
These species are gone for a reason. Who are we to change that? But in a lot of cases, we are the reason they're extinct. So wouldn't it kind of be our responsibility to bring them back if the opportunity presented itself?
No.
But if we did bring them back from non-existence, could we replicate their natural habitat?
Probably.
Is it moral or fair to bring them back just to throw them in a zoo or in a lab?
Definitely not. All I know is I want to be able to proudly walk my ground sloth up and down the block. By the way, neighborhood association, I don't believe in curbing my pet. Deal with it.
And just because it's interesting, follow the link in the description down below to a Wikipedia page listing all the different animal species that we've already cloned. Spoiler alert, it's 22.
What are your thoughts on the morality of cloning animals? Should we continue to do it, or should we not do it ever again and not even try? Let us know your thoughts in the comments section right down there.
And then stalk the like button, feast on the subscribe button, and hit this annotation or go to SourceFed.com for the 5 dino stories of the day or any dino story that we've ever covered here at SourceFed. I'm Joe Beretta.
I'm Elliot Morgan.
We walked a dinosaur! Yeah, we rocked a dinosaur!
So, okay, so that was informative, that was helpful, and what we're going to do now is you're going to work on an assignment where you have reproductive cloning on the one side and therapeutic cloning on the other side. Here's a diagram of that process, okay? And what you need to do is fill in this part, okay? For A, B, C, F, H here, you look at your diagram and you look at your word list and you say, what is A? That is, here's A. What is that? Is that a clone? Is that a skin cell? Is that an embryo, egg cell, nucleus? What is that? Okay, so you're going to label that. Here, you're explaining the process. What is happening at each of the following? So B, what is happening? We had A and we see that. So what is happening at B? Okay. D, what is happening here? Oh, this looks a little bit different than that. Okay. E, what is happening here? Whoop, whoop. Okay, so you're explaining the process, and then you would do that on the other side for therapeutic cloning. So there is a quick explanation of cloning. I hope it made sense. It's kind of exciting, and yet again, we do need Christians to be involved in these discussions.